Hi students, welcome to the science class. In last session under the chapter of atoms and molecules, we studied about what are the atoms, what are the postulates of the Dalton theory, what are the fundamental laws of the chemical combinations. That is the two laws of chemical combinations we have studied, that is law of conservation of mass, and another one is law of constant proportions, isn't it? So but in today's session we are going to continue that last session. So we come to know in last session what is atom and what are the postulates of the atom. But the one question arises in your mind, how we are going to represent an atom? So that question will be arises in the mind of the scientist also. So how we are going to represent an atom, how we are going to name an atom, that will be that the question will be arises in the scientist mind also. So first time that Dalton was the first scientist to use the symbols to represent the atom. He was firstly started to represent the atom using the symbols. He makes some of the symbols to represent an atom. For example, I am taking any example here. If I am going to represent a ball, I am writing as a 0 like that. So round, that is any circle, I am representing a circle, that is to represent a ball like that. So Dalton is the first scientist who firstly used the symbols to represent an atom. So which types of the symbols he used to represent an atom? We can see some of the examples here. So hydrogen atom, he make the symbol like that. He make the symbol like that for the hydrogen atom. For the iron, he make the symbol like this, I, and around the I there is a circle. Like the for the copper also, he used to make a symbol. He make a symbol like C, around the C one circle is there, the copper. Like that for the sulfur, silver, lead, platinum. How many atoms he know in that time, he makes some of this different type of the symbols to represent that atom. So why? Because to know, to represent and to study that atoms, he gives some of the symbols for that atoms. So you have to remember who gives the first symbolic represent for the atom is nothing but the Dalton was the first scientist who gives the symbols for the atoms. So after onwards, for the study, for the symbolization of the atoms, Berzelius suggests to symbolize the atoms by naming, by taking the first letter of the elements. So Berzelius suggests that the symbols of elements should be made from one or two letters of the name of the element. So in the previous, the Dalton used to give the symbols. He uses some of the diagrams or some of the symbols to represent an atom. But Berzelius here suggests that to make the symbols for the atoms of an element, we should use the first letter of the atom for the element which we are going to take the atom. So Berzelius suggests that the symbols of elements should be made from one or two letters of the name of the element. For example, hydrogen, according to the Berzelius, what he suggests here, I am taking example here. If we are going to give the symbol to the hydrogen element, we should use hydrogen I am representing, that is Berzelius representing the symbol for a hydrogen element. So he take the first letter, he represent the hydrogen atom by the symbol of H. So Berzelius suggests that in that way we should symbolize the elements, we should symbolize the atoms of the element. So he at the time of that Berzelius time, they give the symbols for the elements based on their name. But after onwards, they are going to give the names, or they are going to give the symbols based on the where the elements are found. For example, copper I am taking here. Copper firstly found in the Cyprus. So they are going to give the symbol for the copper as a C, but it is not from the copper, but it is from the Cyprus. Cyprus, it is the place where the first copper was found. So based on that, and also they are going to give the name based on their where they first present that element which we are going to see. The place which we are going to see the first that element, using that name of that place, they are going to give the symbols. For example, I am taking here copper. Copper first was found in Cyprus. Cyprus, it is the area which the first time the copper was copper was found. So using the word C from the Cyprus, they are going to symbolize the copper. That's like the Berzelius, he was going to symbolize the elements of an atom. But after onwards, as the studies continued, as the days are going on, the IUPAC, that is, it is an unity, that is, it is an body. So IUPAC, it is nothing but an international union for pure and applied chemistry. It is a body which it is going to study the applied chemistry. It is one of the international chemistry associations which suggests, after IUPAC suggests that symbols of the elements represented by a first letters of its name. So IUPAC also will follow the rules of the Berzelius to represent the symbol of the elements. Why we are going to represent the symbol of the elements? Because we found different types of the elements, n number of the elements. How we are going to separate? For example, in your imagine a classroom is present. So in a classroom, about 60 students are present. How we are going to differentiate the students? How we are going to name? So how we are going to find the differences in the students? First, we can differentiate based on their names, isn't it? We are going to name different names for the different students. So like that, to differentiate the elements, first Dalton started to symbolize the elements based on the sum of the symbols. After onwards, the studies continues. Berzelius suggested that he used to symbolize the elements based on using their names, using the first letter of the name. But IUPAC also, the international body which studies the chemistry, that also suggests that to represent an element, we should take the first letter of the name of the element. So after IUPAC refers suggests the symbols of the elements represented by first letters of the name. For example, hydrogen, we can represent the hydrogen element by the symbol called H, the first letter, that is H, and second one is oxygen, so that is O, like that carbon, C. But it is very easy to symbolize the elements, but here one problem arises when we are going to consider the elements which starts with the same letter, like a carbon, chlorine, calcium. What we are going to do then, that time also the IUPAC suggests, but in a repeated cases like a copper, calcium, IUPAC suggests that first two letters of the name of the element should be taken to represent the element. For the repeated cases, for example, I am taking a copper, I am taking a calcium, I am taking a carbon, they are all starts with a C. But if we are going to name the elements from the first letter, it is very confucius to get the different types of the elements. But in that case, the IUPAC suggests here we should use the first two letters of the element, or we should use the first letter of the element and also remaining letter of the element. So like that, according to the IUPAC naming, they are symbolizes these elements like copper as a Cu, calcium as a Ca, chlorine as a Cl. So here the IUPAC also suggests one important thing, that is when we are going to symbolize the element with the two letters, we should write the first letter of the symbol capital and remaining as a small letters. We should write the remaining letter as small letters. We should write small letters with the remaining letters. For example, I am taking here copper. Copper is represented by the Cu. So we should write the capital letter as a C when we are going to symbolize the copper, and we should write a U as a small letter. Remaining letters we should write as a small letters. Again, I am taking here calcium. Calcium, I am writing first letter as a capital and second letter as a small letter I am using here. We should use first as a capital letter and second all remaining letters as a small letters when we are going to represent the symbol of the elements. Is it clear? But also second time this also one problem arises. Some of the elements has same starting two letters are same in their names. What we are going to do in the symbolization of the elements, in that time we should take the third letter, the fourth letter or the fifth letter of the element name. Like here chlorine, chlorine represents the chlorine contains here. In the chlorine, L will be the third word in the L is the third word in the chlorine, so we can take here L as the Cl directly. Why? Because in the some of the cases the second name also will becomes in a different elements as the same, so in that time we should take next letter of the element. So based on this we are going to represent some of the elements, and we are going to, the IUPAC completely gives the names or the symbols of the all the elements which we are going to find. So some another one continued study and another one changes comes here, that is nothing but some of the symbols of the elements, that is IUPAC also using some of the tricks here. Some of the symbols of the elements are taken from the Latin names. So one confusion arises when you are going to symbolize, when you are going to see the symbol of the sodium, that is Na, but IUPAC says we should write the symbol by using the name of element. So name of the element contains sodium as the words as SODIUM, but the symbol contain here Na. What is the confusion here? But this symbol is taken by the Latin name of the sodium. The Latin name of the sodium, it is nothing but the natrium. Is it clear? So what IUPAC states here, what IUPAC suggests here, we should symbolize the element using the words which are present in the elements, name of the elements. So the name of the element is sodium, but we are not writing as a sodium here, but we are symbolizing the sodium as Na. Why? Because the Latin name of the sodium, it is natrium. So in some cases we are going to symbolize the elements using their Latin name. So another one example here, potassium, we are going to represent potassium by K, but the starting letter of the potassium is P. But why? Because we are using K here, because Latin name of potassium here is Kalium. So by the Latin name we are going to represent the symbols of an element. So that is another one condition which IUPAC refers when they are going to represent the symbol of the elements. So it is all about how we are going to symbol the elements. So now I am discussing another one important topic here, that is atomic mass. As you know already what is meant by the atom, and also you know how we are going to name an atom, how we are going to represent the symbol of an element or an atom. So now I am discussing atomic mass. What is atomic mass? Atomic mass, it is nothing but mass of an atom of an element. So mass of an atom present in an element, that is nothing but an atomic mass. As we know already, element it is made up of number of atoms, 1,000 billion number of atoms are present in a one element. So that element is made up of a number of atoms. So atomic mass here, the mass of an atom, it is nothing but an atomic mass. Mass of an atom of an element is known as atomic mass. What is the unit we are going to measure the atomic mass here? The atomic mass unit. The unit which we are going to measure the atomic mass is atomic mass unit, that is AMU. That is 1 AMU is equal to 1 divided by 12 of mass of a carbon atom. Why we are considering here a carbon atom? Because it is a standard atom which we are going to take a measure, or which we are going to measure other atoms based on the mass of the carbon atom. So 1 atomic mass unit is equal to 1 divided by 12 of mass of the carbon atom. So how we are going to represent the mass of the atom in terms of the atomic mass units. Or for example, the mass of the hydrogen atom, it is 1 units, and mass of the carbon atom is 12 units. Mass of the oxygen atom is 16 units. You have to remember so some of the masses of the sum of the atoms which they are helpful for to calculate in future for the molar mass, molecular mass in the future classes. So you have to remember the atomic masses of the sum of the elements, that is I am considering here hydrogen. The atomic mass of the hydrogen is 1 units. The atomic mass of the carbon is 12 units. Atomic mass of the oxygen, it is 16 units. So you have to remember some of the atomic masses of the sum of the elements. So next Another one thing here, but how the atom is exist? Is it possible to take an atom from an element? Is it one atom can be separated from an element? No, the atom is not exist in a free way. So existence of an atom, all the elements, all the atoms of the atoms of all elements are not freely exist. They are not really exist in a single stage or a single atom. They are combined to the another atom like a molecules. They are combined with another one atom. They are not freely exist in a single atom. For example, oxygen, it is exist in a with another one molecule, that is it will be always freely exist in with the two atoms O2. It is not will be exist as a O1. Oxygen single molecule is, it will be not freely exist. So existence of the atom here, the atoms are not freely exist because they are always exist with a combination of atoms, with the combination of atoms. That combination of atoms are nothing but the molecules. What are molecules? A molecule is a general group of atoms that are chemically bonded together. A molecule is a general group of atoms that are chemically bonded together. It is a group of atoms. I am considering O2. O2 is a one molecule of oxygen. So the two oxygen atoms chemically combined together and they are freely exist. The one molecule of the oxygen is freely exist, but one atom of the oxygen, it is not freely exist. Is it clear? That is nothing but the existence of the atom. Atoms are not freely exist in the nature. They are always freely exist with a combination of atoms called as a molecule. What is molecule here? A molecule is a general group of atoms that are chemically bonded together. So what is the molecule of the element? I am considering only molecule here. What is molecule of the element? The smallest particle of an element which capable of independent existence and shows all properties of the element. What is molecule of the element here? So atom of the element, it is not possible. It is not freely exist in nature. So for to get a free atoms, we should find out group of atoms. That group of atoms is nothing but the molecule. So molecule of an element, it is nothing but the smallest particle of an element. It is also smallest particle of an element which is made up of the atoms and which capable of independently existence and shows all the properties of the element. It will freely independently exist. The molecule of an element, it will be freely independently exist and shows all the properties of the element, that is known as the molecule of the element. For example, oxygen is an element, O2 is a molecule. Oxygen, it is an element, O2 is a molecule, because O2 here two atoms are present. One atom, it is not freely exist. So we are going to, if we get the atoms freely, we should take as a molecules. O2, two oxygen atoms are capable to exist in a free state, so they are called it as a molecules. Example here, O2. Oxygen is an element, O2, that is oxygen, two atoms of the oxygen, it is called it as a molecule, like that. So now I am discussing molecule of the compound. You are clear about molecule of the element here. Another one example I am taking here. Example, you can take hydrogen, H2. If you are going to take H2 molecules, so if the H2 molecule contains two hydrogen atoms, so like that, molecule of the compound. What is molecule of the compound? One example for the compound is water. So what is molecule of the compound? Is the molecule of the compound, it is nothing but it is also the smallest particle of the compound. It is also the smallest particle of the compound which capable of independent existence, and shows all the properties of the compound. I am taking what is here, what is the molecule here? Water, H2O. If you are going to take the water molecule, one water molecule, H2O, it is a one water molecule. So the water molecule always present, it is not present in as an atom, so it is a group of atoms. So what is the molecule of the compound here? The smallest particle, it is the smallest particle of the compound and which capable of independent existence, because the smallest particle, it is always freely independent. We can take a small particle, the small unit of the water or the small drop of the water. It isn't it. It is the smallest particle of the water drop. So like that, the molecule of the compound, it is the smallest particle of a compound which capable of independent existence and shows all the properties of the compound. So if you are going to check the properties of the small drop of the water, that will shows the same properties of the water which is present in a bottle or water is present in any tumbler. You are going to consider only small drop, that is as a molecule. So what is molecule of the compound here? It is also smallest particle of the compound which capable of independent existence and also shows all the properties of the compound. So that is the molecule of the compound. Based on the number of the atoms or the type of the atoms present in a molecule, we are going to differentiate two types of the molecules here. So those are homoatomic molecules and heteroatomic molecules based on the different types of the atoms present in the molecule. For example, if a molecule contains same types of the atoms, similar types of the, not as similar, same types of the atoms, then that molecule it is called as a homoatomic molecule. For example, I am taking oxygen molecule, that is O2. Here two oxygen atoms are present. Those are all same atoms, that is one oxygen atom and another one oxygen atom. Two oxygen atoms are present in a one oxygen molecule, therefore that is a homoatomic molecule. And O3, three atoms of oxygen present in a oxygen molecule, therefore that is a homoatomic molecule. So what is homoatomic molecule here? A molecule which contains the same types of the atoms, that is called as a homoatomic molecules. And what is meant by a heteroatomic molecule? Heteroatomic molecule, it is nothing but a molecule which contains different types of the atoms, different types of the atoms present in a molecule. I am considering one example here, that is water molecule. Water molecule contains two types of the atoms, that is one is hydrogen atom, another one is a oxygen atom. That is, it is called it as a heteroatomic molecule because it contains two types of the atoms, that is one is a hydrogen atom, another one is a oxygen atom. But when we compare to the homoatomic molecules, they contain same types of the atoms, that is all two are same, that is oxygen atoms. But in the heteroatomic molecules, there are two types of the atoms are present, that is two or more types of the atoms are present. That is, I am considering water as an example. Under one example, I am taking CO2, carbon dioxide and molecule. Here also it is also one heteroatomic molecule because two types of the atoms are present. One it is carbon, another one is a oxygen. So if the molecule contains different types of the atoms, then that molecule it is called as a heteroatomic molecule. Now I am going with atomicity. Another one important concept here, that is nothing but the atomicity. What is atomicity? What is meant by the atomicity? The number of the atoms present in one molecule of an element is called it as its atomicity. For example, what is atomicity here? The number of the atoms present in a molecule. I am taking oxygen molecule here, two atoms are present. So the atomicity of the oxygen here, diatomic. Oxygen molecule, the oxygen molecule has two atoms of the oxygen, therefore the atomicity of the oxygen is diatomic. So what is atomicity here? The number of the atoms present in one molecule of an element is called it as its atomicity. I am considering some of the examples here. Argon molecule exists in a single state. The atom of the argon exists in only one atom, so therefore it is a monoatomic. The molecule argon molecule has only one atom, therefore it is a monoatomic. I am considering helium. Helium also, here the molecule of the helium also has only one atom of the helium, therefore it is also monoatomic. And oxygen, the oxygen molecule contains two atoms of the oxygen, therefore it is diatomic. And hydrogen also, the molecule of the hydrogen has two atoms of the hydrogen, therefore it is also diatomic. So what is monoatomic, diatomic? What it is nothing but the atomicity of an element. The number of atoms present in one molecule of an element, it is called it as atomicity. Then under one important concept here, ions. What is meant by the ion? Ions, the compounds composed of metals and non-metals contain charged species. You have to remember here, the ions are nothing but the charges of the atoms, charges present on the atom. So what are ions here? compounds composed of metals and non-metals contain a charged species. The charged species is known as ions. So the atoms contains, the compounds contains some of the metals and non-metals. On the metals and non-metals and or metals and non-metals carries some of the charges. That charges are nothing but the ions. So there are two types of the charges. One, it is a positively charged particle, another one is a negatively charged particle. So positively charged particles are called it as a cations, and negatively charged particles are called it as a anions. So positively charged particles are nothing but sodium plus. Plus means positively charged particle, and another one is hydrogen plus. That is, these are positively charged particles, and negatively charged particle chlorine Cl minus. This is anions. The positively charged particles are called it as a cations, negatively charged particles called it as a anions. And if you have to remember here, based on the valency, we are going to write down the number of charges here. What is valency here? Valency, it is nothing but the capacity to share the electrons with the another one atom. It is nothing but the valency of an atom. What is valency of an atom? Valency, you have to remember here, valency. What is valency? The capacity of an element, the capacity of an atom to share charges, to share electrons, or ions to the other atom, is known as the valency of an element or a valency of an atom. So based on the valency of an atom, we are going to write here the charges. What is meant by Na plus here? So Na plus will be the, what is the capacity, what is the valency of the sodium, because it is only 1 plus, therefore we are writing it as a Na plus only. So some of the elements, they are have, I am taking some of the examples here. For example, and some of the examples are comes. So the capacity, the valency of the atom, it is more than 1, that is a 2 plus plus. Some of the comes Ca plus plus, calcium plus plus. They are, why we are going to write down 2 plus plus here? Because the valency of that atom is 2. So based on the valency of the atom, we are going to write down the charges here, 1 plus, 2 plus, or 1 minus, 2 minus. So that is nothing but the ion. So once again I am repeating here, what is ions here? Ions are nothing but the charges present in the atoms, or the compounds composed of metals and non-metals contain charged species. The charged species is known as the ions. So positively charged particles are called it as a cations, and negatively charged particles are called it as a anion. So in the next session we are going to discuss what is meant by the chemical formulae, what are the steps how we are going to write the chemical formulae, what are the conditions we should follow to write the chemical formulae. That will be studied in the next class. Okay, thank you.